So the first question is here where they're asking you to find limit of f of x extends to infinity. The question is root of x plus sin x by x plus cos square x. So since it's infinity, you have to somehow bring the x down. So it's 1 minus sin x by x by 1 plus cos square x by x. Now this is 1 by something by infinity, because sin x value lies between minus 1 plus 1 by infinity, which is 0, and this cos square x also minus 1 plus 1 divided by infinity is 0. So therefore is root of 1 by 1. So answer is just 1. So C is the right answer. So let's go to next question. If g of x is equal to, this has been given a function, g of x, limit of x tends to 1, g of x minus g of 1 by x minus 1. What is g of x? Is minus root of 25 minus x square, minus g of 1 is minus of minus root of 25 minus 1, which will become root of 24 by an x minus 1. So this itself is, if you put limit x tends to 1, in the place of x you put 1, it will become a minus 24 minus root 24 plus 224, so 0 by 0 format. So if that's 0 by 0 format, you have to only think of differentiating. So then if I differentiate L, I'm going to apply L'Hopital rule. So it's minus 1 by 2 into root of 25 minus x square into 2x with a negative sign, so it makes it positive. The 2 and 2 get cancelled, plus 0 by 1. So now limit x tends to 1, you will be 1 by root of 25 minus 1 is root of 24. X tends to 1 by root 24. So I don't think we have only 1 by 24. I don't think anything is the right answer here. So I think none of them is the right answer. Let me check that once again. Yeah, so then none of them. If the question in the option A, if it's 1 by root 24, then we could have marked that as the right answer. Okay, so let's go to next question. In this n tends to infinity, the LCM is all the same, so it's 1 minus n squared. 1 plus 1 plus 2 plus 3 till dot 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 n is n into n plus 1 by 2. And you can now limit n tends to infinity again. You can split the denominator as a plus b into a minus b, so 1 plus n into 1 minus n. So whenever it's limit n is tending to infinity, you have something like this. There's a trick. What is the trick is, just write the coefficients, highest powers coefficient, or in other words differentiate the numerator and denominator. If you differentiate L'Hopital rule, this will become 1, and this when you differentiate you'll get minus 2. So then just applying L'Hopital rule you get, or in other words you can also take the highest power of the numerator and the highest power of the denominator and write it as answer when n is tending to infinity. So in fact it's not, you shouldn't say differentiation. When n is tending to infinity, we just take the highest powers of the numerator and highest power of the denominator and write the answer. Oh, I hope it's clear. So let's go to next. This is greatest integer function. When x is greatest integer function is not equal to 0, and when greatest integer function is equal to 0. The fact that greatest integer function is equal to 0 shows that x has to lie between 0 and 1. That's when x value will be 0. So then let's do a left hand limit. Limit of x tends to 0 from the left, x will become a 0 minus h. So then when you apply that, sign of greatest integer function of 0 minus h by a greatest integer function of 0 minus h. A 0 minus h is coming to 0 from the left, so the greatest integer functions will be sign of minus 1, and this will also be minus 1, and sign of minus 1 is minus sign 1 by minus 1. So the answer therefore is plus sign 1 for the left hand limit. We don't have any of these as the answer, so none of these is the right answer. But let's do the right. This is about left hand limit. Let me do the right hand limit. X tends to 0 from the right. You know that the answer for that you don't have to do it, because straight away is 0. And but the right hand limit is 0, but the left hand limit and the right hand limit are not tallying, so none of this is the right answer. Limit does not exist. So let's go to next question, where this is the question. The limit x tends to 0, root of half into 1 minus cos 2x. 1 minus cos 2x is 2 sin square x. So root of half into 2 sin square x, where this and this get cancelled, by an x, which itself is to be sin x by x. Sin x by x. And limit x tends to 0. This answer itself is 1, thus A is the right answer. Let's go to this question, where x tends to 0, but 1 by x square has been given, so this is 1 by 0 which is coming as infinity. So whenever you have such a format in algebra, you can write as e to the power limit of x tends to 0. The power can be brought forward and the function can be repeated again with a minus 1. So then solve it. E to the power limit of x tends to 0, 1 by x square into 3x square plus 2 minus 7x square minus 2 by 7x square plus 2. So the 2 and 2 get cancelled. The limit of e to the power x tends to 0, 1 by x square into this is minus 4x square by 7x square plus 2. Okay, and so then now if we put x as x square and x square get cancelled, so minus 4 by 7x square plus 2, and when you substitute x as 0, you get this is e to the power, and so then e to the power minus 4 by x as 0, e to the power minus 2 is the right answer, so 1 by e square is the right answer. So whenever you have a format where it's becoming infinity in the power, it's function to the power function format. Function to the power function format in algebra can be written as e to the power, bring the 1 by x square and the function minus 1. So let's go to this question where can you see x can be taken out common. A tan 2x minus 2 tan x by a 1 minus cos 2x is 2 sin square x the whole square. Limit x tends to 0. So then therefore this is x into what is tan 2x formula? 2 tan x by 1 minus tan square x minus 2 tan x by a 4 sin to the power 4x. So when you solve this, you get a 2 tan x minus 2 tan x plus 2 tan cube x, this and this get cancelled, by a 4 sin to the power 4x. Limit x tends to 0. Now you can write this as sin cube by cos cube. So x into 2 into sin, 2 and 4 will get cancelled, so it will become 1 by 2. So 1 by 2, 2 in the denominator, as sin cube x by cos cube x into sin to the power 4x, where this and the power get cancelled. Thus you can take this x in the numerator and bring it down, and sin x by x limit x tends to 0 will be 1. So what are you left with? You're left with a 1 by a 2 cos cube x, and cos 0 is 1, so 1 by 2 would be the right answer when you substitute x as 0. So do you have an option? You have 1 by 2, yeah, and so then 1 by 2 is the right answer. So let's go to next question. Okay, so this is cos x minus 1 into cos x minus e to the power x. They have given that the limit is a finite value and is a non-zero value. They've already given it cannot be 0, it cannot be infinity. The answer. Okay, so then let's do it. A 1 minus cos x is 2 sin square x by 2, but this is negative sign because cos x minus 1 into cos x minus e to the power x by an x to the power n is there. You have an x sin square x by 2, you need an x square by 4, so multiply and divide by 4. From the x to the power n, you've taken x square, so x to the power n minus 2 would become, and this itself is becoming 1, and the 2 and 4 get cancelled. You get a minus 1 by 2 into cos x minus e to the power x by x to the power n minus 2. Now, when you apply L'Hopital rule, since they've already given that's a finite answer, and you put n is equal to, let's put n is equal to 1, option A. What does it get to? Cos x minus e to the power x by n is equal to 1 means x to the power minus 2 will become x square, and limit x tends to 0. If you put this x square will make it 0, the answer becomes 0, which is not possible. So the next case, let's put n as 2. If you put n as 2, minus 1 by 2 into cos x minus e to the power x by n as 2 will become x to the power 0, which is x, and again limit x tends to 0, which will make it infinity format, and so therefore this is also incorrect. Let's put n is equal to 3. Minus 1 by 2 into cos x minus e to the power x by, when you put n is equal to 3, it will become x. And the advantages, you can now differentiate the numerator separately, L'Hopital rule, and differentiating numerators minus sin x minus e to the power x by denominator is 1. So when you do this and put limit x tends to 0, this is sin 0, which will be 0, minus half, a sin 0 is 0, minus e to the power 0 is 1 by 1. So you are having minus and minus get cancelled, thus you are getting 1 by 2 as the answer. Thus n can be 3. Okay, what about n can be 4? Yes, n can also be 4. In which case I'll get it will be cos x minus e to the power x by x square. So in this case I have to differentiate it, I have to apply L'Hopital twice, so it will be minus sin x minus e to the power x by 2x, and then if I again differentiate, it will be minus cos x minus e to the power x by 2, and then if you put x as 0, it's minus 1, yes, but having said that, what is the minimum value at which is what you need to see, and so then that if it is x, it will become 1, and therefore n has to be equal to 3. So let's go to next question. So the next question is this, where limit of x tends to a minus n into nx minus tan x into sin nx. So the limit itself has been given to be 0. So a minus n into x minus tan x by a sin nx, you take 1x here, keep another x here, multiply and divide by n, so that limit x tends to 0, this part is becoming 1. So then you left with limit x tends to 0 and n into a minus n into nx minus tan x. Let's split this up, and this itself is 1. The x and x will get cancelled, limit x tends to 0, n into a minus n into n minus 1. And if this is equal to 0, the n will become obviously 0. So a minus n into n is equal to 1. You have to find what is a from here. So a is equal to 1 by a minus n is equal to 1 by n. So a is equal to 1 by n plus n, and therefore D is the right answer. Beautiful sums, okay. So let's go to next question. So let's look at this question where this function, denote the greatest integer function of tan square x, okay. So let's do the left hand limit of x tends to 0 from the left. In that case it will be x will be 0 minus h. On substituting here, it's a greatest integer function of tan square 0 minus h. It's an ordinary, this is an ordinary 0 minus h, greatest integer is outside. And so 0 minus h, tan square 0 minus h will be just 0 because h is 0. So you have greatest integer function of tan square 0, and tan 0 is 0, and the greatest integer function of 0 will be just 0. So that's the left hand limit answer. Let's do the right hand limit of x tends to 0 from the right. So it will be x is equal to 0 plus h in that case. So greatest integer function of tan square 0 plus h, and 0 plus h is just 0 again. Tan square 0, a greatest function of it is again 0. Therefore left limit is equal to right limit, and therefore it's continuous. F of x is continuous at x is equal to 0 is the right answer. Limit of f of x does not exist at x is equal to 0. No, it exists, we just saw it. So that's the B is the right answer. So next question is this. There's a greatest integer function of x and a cos of 2x minus 1 by 2 into pi is discontinuous. Okay, the fact that this is a greatest integer function, you know, for all integers it is going to be discontinuous. We know that. So can I say for all integer points and mark this answer as B? No, because you also have to see this. So let's consider some random x is equal to k be the integer. So in that case it's going to be a greatest integer function of k into cos 2k minus 1 by 2 into pi, which is pi by 2, an odd multiple of pi by 2, whose answer will be 0. So every time for every k value of integer you take, the answer will always tend to be 0. And it does not depend on, the answer is always 0, the limit is always 0 irrespective of the value of k. So it's discontinuous at all x. We thought it could be discontinuous at all integers, but having said that, we are getting answer as 0. Whatever be the value of k, the limit is becoming 0. So for no value of x it's discontinuous, because when you put when you keep on putting 1 values of x, it answers always 0, which means the limit at every point is turning out to be 0. So it's discontinuous for no value of x, and that is the answer. Okay, by mistake also we should not write all integer points. So read this question. F of x is equal to greatest integer function of x the whole square minus greatest integer of x square. Okay, so then is this continuous at all integers? Okay, so let's do the left hand limit and right hand limit. Limit of f of x extends to 0 from the left. You know, x can be written as 0 minus h. So in that case, this will be greatest function of 0 minus h the whole square. Extending to 0 from the left. Okay, so then therefore, let me continue. 0 minus h the whole square minus greatest integer function of 0 minus h the whole square. So when you do this, you'll get 0 minus h, and the greatest integer function would itself will be minus 1, and minus 1 the whole square will be 1, minus 0 minus h again is minus 1, and 1 minus 1 is getting to 0. Okay, 1 second, hold on. Okay, just thinking about this sum, why did I assume x tends to 0? Where have they given that is tending to 0? They have not mentioned anything like that. So I have to assume some random k, that it's approaching some random k value, correct? So then limit of f of x, x is approaching k from the left, some and integer k value from the left, you know, then it will be k minus h. So then therefore you can write this will become a k minus h the whole square minus a k minus h the whole square, the greatest integer function. So in that case, when the greatest integer function of k minus h is already approaching k from the left, so it will be k minus 1 the whole square minus, this is also k minus h, but here h can be 0, so it will be k square, and the greatest integer of k square is k square minus 1. So this is what you get, and then you can write it as a plus b into a minus b. So k minus 1 the whole square minus k plus 1 into k minus 1. So k minus 1 is completely common, a k minus 1 plus minus k minus 1 again. K and k get cancelled, so it's k minus 1 into minus 2 is all I get. And in this, if it's all I get, and x is tending to k. So this is my left hand limit. So let's try for right hand limit. X tends to some random value k plus. So in this case, x k will become, you can write x as k plus h. So then therefore it will become k plus h the whole square minus greatest function of k plus h the whole square, this. Okay. So then therefore if you see, is k plus h which is approaching k from the right. Approaching k from the right, it will still be k square. It's slightly greater than k and the x value, so then therefore it's k square k, and so it's k square minus k plus h the whole square. K plus h itself is approaching k from the right, which is only k. So minus this will also become k square, and the greatest integer function of k square is k square minus 1. Okay, so then it's k square minus k square plus 1. K square get cancelled, you get answer as 1. So for the left hand limit is dependent on k, the right hand limit is independent of k. Okay, so then for the left hand limit to be equal to right hand limit, say minus 2 into k minus 1, I am just trying something, k minus 1 is equal to 3 and k is equal to 4. Only for k is equal to 4 it is continuous. Can I say that? But that option is not even there. That option is not even there. I know the left hand limit can be equal to right hand limit only at k is equal to 4. I'm just thinking what, once again. I think I made a mistake here. Can you see? It's k plus h the whole square, and you're approaching, this is not, this itself inside is not a greatest integer function, but substitute h as 0. You get k square, and the greatest integer function of k square, greatest integer function of k square will be just k square, Greatest initial function of k square will be just k square. Why did I write k square minus 1? So therefore I'm getting answer to be 0. So when I equate this left hand limit with right hand limit, so I'll get a minus 2 into k minus 1 is equal to 0. The k minus 1 is equal to 0, k is equal to 1. Thus at k is equal to 1 is the only point where it's going to be continuous. Rest of the point it's all going to be discontinuous. I made a mistake here. I hope you understood. It's k plus h the whole square is an ordinary function where h tends to 0, it's k square. And this is now at k square, the greatest function of k square is just k square. That's where I made a mistake. I'm sure you understood. I'm sorry guys. So let's go to next question. So let's go to this sum where it's let f of x is equal to x square by 2 when x is lying between 0 and 1, and 2x square minus 3x plus 3 by 2 when x is lying between 1 and 2. So therefore you understand that you're going to study for, you're going to approach one from the left and one from the right. So limit of f of x extends to 1 from the left, and limit of, okay, but with the left, 1 from the left, the formula is x square by 2, direct substitution 1 by 2. Limit of f of x extends to 1 from the right. 1 from the right will be the 2x square minus 3x plus 3 by 2. Substituting 1, you get 2 minus 3 plus 3 by 2, which is minus 1 plus 3 by 2, which will be 1 by 2. So left hand limit is equal to right hand limit. This is left hand limit and this is right hand limit, and both of them are equal. So limit exists at for f of x. Okay, discuss the continuity. And so then therefore continuity is there for 1 because they have already given it to be 1. Now we're going to check what is f dash of x. So let f dash of x, you have to redefine the function, will be 2x by 2. It will just x when x is lying between 0 and 1. And this one will be 4x minus 3 when x is lying between 1 and 2. So this is how we redefine it. And now let's see the left hand limit. Let f dash of x, that is let's consider this as a new function. We can even consider as g of x, where f dash of x be equal to g of x. So in that case, limit of g of x extending to 1 from the left. If you put it, you'll get the answer as 1 from the left. 1 will be the answer when x is 1. So you get this is x and it will become 1. For right hand limit, you know, limit of g of x when extends to 1 from the right. 1 from the right, the formula is 4x minus 3, where you should substitute x as 1 and you'll get answer as 1. So LHL is equal to RHL, so limit exists for f dash of x also. Let's now redefine f double dash of x. Let f double dash of x, where f double dash of x can be called as h of x. Okay, so then we can also call it as, which can be written as 1, and this can be written as 4 when x is lying between 0 and 1, and when x is lying between 1 and 2 by differentiating this. So you found what is f double dash of x, and you're going to call it as h of x. So limit of h of x extending to 1 from the left, and 1 from the left, answer itself is 1. When you do that, you will get answer itself to be 1. A limit of h of x extending to 1 from the right, answer itself is 4. Left hand limit is not equal to right hand limit, so limit does not exist for f double dash of x. So that's the answer. So I hope discuss the continuity. This is the way you should represent. So here is a sum where f of x is equal to greatest integer function of x sine pi x. At x is equal to k, you have to find the left hand derivative. Left hand derivative's formula is f of x minus f of x minus h by h, or f of x minus h minus f of x by minus h.